Okay, we've looked at how much energy is required to change the temperature of a given material a certain amount. Right, we looked at specific heat of various materials. How many kilojoules of energy it would require to change the kilogram of a substance 1 degree Celsius. Now we're going to get started on latent heat. Here's a couple of questions for you. We know that water freezes at 0 degrees Celsius, right? Or ice melts at 0 degrees Celsius. Well, the question is, at 0 degrees Celsius, is water a liquid or a solid? Which one is it? Likewise, we know that water boils at 100 degrees Celsius and becomes a gas. Or if you cool that gas to 100 degrees Celsius, it becomes a liquid again. So at 100 degrees Celsius, is water a liquid or a gas? Now, the answer is very shocking and very alarming. At 0 degrees Celsius, water can be either. So at 0 degrees Celsius, water can either be a liquid or a solid. It can be liquid water or solid water at 0 degrees Celsius. At 100 degrees Celsius, water can be a liquid or a gas. There's a phase change that happens here. Now, adding heat does not always change the temperature. Sometimes heat is used to change the phase. Okay, so what we do is we have ice at a certain temperature, like -5, and we heat it up to 0 degrees Celsius. Then we have to put more energy into that ice at 0 degrees Celsius to just change it from ice to water. And then we can put more energy into the water and it'll warm the water up. When we add heat and the temperature does not change, but the phase of the material changes, the heat is called latent heat. Latent is a word that means hidden. Some people have latent talents. Those are talents that are hidden away, and they may appear sometime in the future. Latent means hidden. So when we add heat and the temperature does not change, but the phase does, it's called latent heat. Because we normally associate heat with a temperature change, adding energy in to changing the temperature. But in this case, we're going to add some energy in. The temperature will not change, but the phase will change. If we add energy in, it will go from like a solid to a liquid, or from a liquid to a gas. If we take energy away, it'll go the other way. So the latent heat of fusion. Here we've got these two words, the latent heat of fusion. This one describes the change of state between solid and liquid. Describes the change of state between solid and liquid. So it describes melting and freezing. Now, the latent energy of fusion is the amount of energy it takes to melt a kilogram of an object without changing the temperature. So the latent heat of fusion, so I think we could call it H sub F, is equal to the amount of energy needed to melt or freeze 1 kilogram of a substance without changing the temperature. Okay, so the latent heat of fusion for water is 3.35 times 10 to the power 5 joules per kilogram. Now this one's in joules. We like to go to kilojoules instead of just joules, which means that 3.35 times 10 to the 5 joules of energy are needed to change 1 kilogram of ice at 0 degrees Celsius into water at 0 degrees Celsius. No temperature change. Phase change. So if you look at this diagram in your book, you see that you've got all these water molecules in this ice, and they're joined together with chemical bonds. You toss some energy in them. Those molecules vibrate more, and eventually they vibrate enough to break the chemical bonds, becoming liquid. Sorry, they're not really chemical bonds. They're electrostatic bonds. Electrostatic bonds. And then it becomes a liquid. And the ice is at 0 degrees Celsius. You add in this much energy, it will melt and become water at 0 degrees Celsius. If you have water at 0 degrees Celsius, you take out this much energy, and it will become a solid again. Right, so latent heat of fusion is for solids and liquids melting and freezing. Latent heat of vaporization. This describes the change of state between liquids and gases. So we've got evaporation, condensation. And it is H sub F is equal to the amount of energy needed to condense, evaporate, one kilogram of a substance without changing the temperature. All right, so the latent heat of vaporization for water is 2.26 times 10 to the 6 joules per kilogram. Usually we put it in kilojoules. We have a chart of these on here. Heats of fusion of vaporization. You can see for water. Where's water? I'm sure water. The melting point, we got the melting temperature. There's the heat of fusion in kilojoules per kilogram. And there's the heat of vaporization in kilojoules per kilogram. Okay, so we have water, liquid. We want to evaporate it, boil it. We have to add this much energy for every 1 kilogram to change it from 100 degrees Celsius water to 100 degrees Celsius steam, and vice versa. All right, so heat of fusion is the amount of energy it takes to change phases from solid to liquid or to go from liquid to solid. Heat of vaporization, the amount of energy it takes to change phase from liquid to gas or gas to liquid. Now, if we look at the top question here, why are steam burns more dangerous than water burns? Well, a burn, the amount of energy something has, depends on its temperature and depends on its phase. Okay, so water has a lot of energy in it. But to change water to steam, even if the water is 100 degrees Celsius and the steam is 100 degrees Celsius, the steam has much more energy. That means steam can burn you far worse than just plain water can, because steam has much more energy in it than liquid water does, because you have to add in a lot of energy to convert the water at 100 degrees Celsius to steam at 100 degrees Celsius. So that steam can have a lot of energy in it. All right, so we'll look at the formula in the next video.